So let's go over your do now and fluency practice. So our bar graph here is titled Bird Sanctuary. So the data collected is about different birds and their migration patterns to said sanctuary in spring. So once again, if we look along the x-axis, left and right, we've got our different birds. And then if we look at our y-axis, that's measuring our number of birds. So once again, for any given bar, we go left and right, we identify the bird it's talking about, we see how high it goes, and that is the value that that particular bird has. So 15 pelicans migrated, and we can see here there's no number on the y-axis, but it's in between 10 and 20, and there is only one line in between, so it must be counting by 5. So that's how I knew this was 15. And that's actually our question in number 1. How many pelicans migrated? 15. How many more wood thrushes migrated than pointed storks? So we see our wood thrushes, there were 60, and the pointed storks, there was 25. So how many more? That's a difference problem, subtraction. So I subtract, and I get that there were 35 more wood thrushes. And now, once again, we needed to make a ratio of mallard ducks to Kentucky warblers. So the mallard ducks, there were 30. The warblers, there were 40. So my initial ratio was 30 mallards to 40 warblers. However, that was not an option, so we can always make an equivalent ratio by multiplying or dividing both sides by the same number. In this case, I divided both sides by 10 to get a 3 to 4 ratio. Once again, order matters, so 4 to 3 would not be an appropriate answer. We've got our middle row. First one, as the past 2 days, is just your typical long division. I can see that 3 fits into 26 8 times, and 3 times 8 is 24. I subtract, and every time after you subtract, you bring down the next number, and 3 fits into 27 9 times. And now the next 2 rows that we're looking at, we can see that our divisor is a decimal value. And so we do not ever want to have our divisor as a decimal. So to fix that, we can multiply it by a base 10 number to convert it to a whole number. So here I just needed to move the decimal place over 1 to turn it into 3. So I'm going to multiply by 10. If you do it to one side, you must do it to the other side as well to keep it equivalent. And then I divide here. Same thing as before. The only difference was there was a decimal here, so I needed to have a decimal in my quotient. And number 6 is the same thing. This time, though, I needed to move it over 2 spaces, so I multiplied by a base 10 number with 2 zeros to move it over 2 spaces, and did it to both sides. And I actually got the same quotient as I did in number 4. Down below, we're looking at a ratio. Someone named James was measuring how far they ran and how far they biked. The initial ratio was 4 to 12. And then I simplified it to a unit rate because I could divide both of these by 4. So I wrote the equivalent ratio of 1 to 3. And once again, that's a unit rate because it's a ratio per 1. Over here, if the ratio of miles run to miles biked stays the same, how many miles will James bike if he runs 20 miles? So there's 2 ways that we could have done it. We could have multiplied 4 by 5 to quintuple. Quintuple is another word for multiply by 5. So if I multiply his miles ran by 5 to get 20, then I could also multiply this by 5 to get 60. So once again, we can always use a ratio table. And if you want to go from one row to another one, if you multiply both numbers by the same thing, then you will get an equivalent ratio. I also noticed that moving horizontally from left to right, that the miles biked is always triple the amount of the miles ran. 4 times 3 is 12. 8 times 3 is 24. 12 times 3 is 36. So if I wanted, I could have also just tripled this. So when you're working with ratios, if you can find that relationship between the 2 numbers, you can use that to solve as well instead of multiplying both sides by the same number. And then once again, here's my graph, which you can just see. Miles ran is the x-axis, miles biked is the y-axis. So when he runs 4 miles, so over to 4, he went 12 miles on his bike. And you can just see those values kind of laid out on my line. And then on the next page, we've got our fluency practice. So this fluency practice is kind of a combination of the previous 2 days, because we need to use the distributive property, which is when you have that number outside of the parentheses and you're multiplying by every number inside the parentheses. And we're also combining like terms, meaning that when terms, a number has the same variable attached to it, we can then combine those, whether that's adding or subtracting. So for all of these, I showed when I did the distributive property. A lot of people like to use these arrows to represent that. And so after I did 3 times x, 3x, and 3 times 2 is 6, I rewrote my expression, but having had this multiplied out, and then I see my like terms, 4x and 3x, both have x's, so those can get together to make 7x. 6 is the only number without a variable, so it just stays the same. Same thing here, 5m and 3m can be added together because they both have m's. This is an interesting one, once again, so we're doing that distributive property. We're multiplying out. 6 times 4x is 24x, and 6 times 7 is 42. Rewrote my expression. I see that 24x and 8x are like terms, but this 8x is subtracting, so I need to subtract 8 from 24 to get 16x. Okay. And then once again, when you get more terms, when it gets a little bit more like there's just more things happening, that's when I started my underlining process. So once again, that's optional, but for some people it's really beneficial. So like I'm like, okay, so I underlined 12y, and then I looked for any like terms. Here's 4y, so I underlined that. And then I saw 15 and double underlined it, and I looked for a like term of that and double underlined it. So the reason why I'm doing that is just because the numbers aren't next to each other, and just to like kind of keep my brain organized, it's easy to be like, look for the single underline and know those are like terms and these are like terms because they both have 2 underlines. So I did that for the more complicated problems down below. And then so an explanation was down below. So I chose to explain this problem. No, not that problem. This problem. Yep. So once again, I used the distributive property to multiply out and rewrote my expression. I underlined my like terms. So 3x and 12x both had x's, so they got 1 underline, and these two both had y's, so I double underlined those. And then I combined my like terms to get 15x plus 5y.